welcome back to the Advent of Sintran. This is day 12. Looks like I'm live. Let me check my audio. Cool. Everything seems to be working. Yeah. So I did day 11 off stream. Hit space in the wrong window. Started a fraction of a second OBS recording, but I'm still streaming. I did that a few days ago, but I had a good streak of not accidentally doing it again until tonight. So I did day 11 off stream, and we've got 2 minutes until today's puzzle unlocks. I had to cheat for day 10 part 2. Almost everybody that I saw did day 10 part 2 using a library, just some integer programming library in Python or whatever language. So that's basically what I ended up doing. I wouldn't have even known that this was something called integer programming. I know what linear programming is. I was thinking it was some sort of linear system. So I learned about integer programming, and I used Python to do that. It's like linear programming, but you're restricted to only integers, so that makes it difficult. I didn't want to implement that myself. I did see at least one person do day 10 without libraries, and it looked kind of grueling. So I don't know, maybe there's an easier way to do it. I've heard some rumors. I haven't seen much that's concrete. And then day 11 was like a nice, refreshing, relatively easy day. But I did that off stream. If I streamed day 11 today, I don't think I would have had the energy to stream day 12 at midnight here. I couldn't do 11 at midnight. I was so burned out after trying and failing day 10. So I did day 11 earlier today. And then that brings us here. Yeah, nice, refreshing. Not too hard problem for day 11. So hopefully day 12 isn't too hard, and this will be the moment of truth. Do we have one part or two parts for the final day here? Usually, in past years, there's only one part on the final day, but because there are only 12 days this year, I don't know if that trend will continue. So 10 seconds. We are about to go. There it is. So I won't know if there's a part 2 until I finish part 1. So I've got my input. 1,000 lines. Looks like a grid. What is this, Game of Life? Sliders? Gliders? Let me get my test input. And then there's some extra stuff at the bottom of this file. I think I got some random new lines in here. I think those are gone. Are they always 3 by 3? Oh, we've got a lot of numbers at the bottom there. Is this a packing problem? I hope not. That sounds hard. Oh, there's not much. We only have 5 of these. Oh, God. Yeah, this is going to be a packing problem, isn't it? 0 through 5. So there are actually 6 shapes. And then 6 shapes in the test. Are they the same shapes? No, they are not the same shapes, but there are 6 of them. All right. I should be able to echo the test input. There we go. So what are we doing? Cavern full of Christmas trees. Yeah, it's a packing problem. The size of the region and a list of the number of presents of each shape. So 4 by 4, and then 6 numbers. 12 by 5, and then 6 numbers for the 6 shapes. Okay. Don't really need the index, right? That's kind of implicit. Oh, can you rotate? Oh my god. Yep, get that. Presents can be rotated and flipped. So you have 8 options, assuming there's no symmetry. Oh my god. This sounds kind of rough. Can't overlap, but they can. They can fit into each other's empty space, basically. How many of the regions? This sounds really hard. Jesus, man. And these are a lot. Like, I guess I could brute force it. Just brute forcing it is going to take a lot of code, I feel like. But can this be brute forced? I feel like brute force isn't going to scale to like a 40 by 40 grid with 20 to 30 of each shape. Because you have 8 permutations for how the shape can be rotated. You have 1, 2, 3, 4 rotations, and then you have the mirror images of those 4 rotations. So 2 times 4 is 8 total flip and rotate orientations. And then you have about 40 squared permutations of where you can put like one corner of that present or that shape. I'm going to call them shapes. So like 40 times 40 times 8. You have like 12,000 ways to place just one of these shapes. And then you have about 300 shapes that you need to place. Okay, that's not astronomically large. Maybe we can just brute force this. Oh my god. Well, this is going to take a while. I don't know if I'm going to finish this tonight. I'm well rested. I didn't stream at midnight last night, so I got like a full 8 hours of sleep. It was fantastic. First one of those nights in like all week, since the weekend at least. But I don't want to stay up much later than 1. So we'll see how much I can do, but I don't know if... have some confidence. Maybe this will work. So we just have to like parse the input first, which is kind of annoying. So how am I even going to do that? Well, okay, the top part is a fixed number of lines because they're always 3 by 3 and there are always 6 presents, regardless of whether it's not dead, head. 0, 1, 2, 3, 4, 5. Okay, the indices are in order. That's good. Because, like, what if they threw you off and, like, put 4 and 5 in the opposite order? And then, like, it messed up your logic of which shape was which. That would be just mean. But Eric's not that mean. Okay, so we have, like, a fixed size for the first part of the file. And then we just have a certain number of lines for the rest of the file. So it's actually going to be the first 30 lines are always the shapes. And then we have the number of lines in the file minus 30 is the rest of the input. And we could just... Yeah, I'm thinking I have a helper function to load a matrix from a file, even with custom delimiters. So I can make X a delimiter and read this whole matrix if it was in the file by itself. But this part kind of messes me up. I could write a different helper or like copy this to another file, but I think I can just parse it manually without too much trouble. Okay, so let's count the number of lines. So 33 lines. So there's only 3 lines that are not just the header. Okay. So let's get the shapes. There's 6 shapes. So we're going to read a line for the index and basically ignore that line and then get the next 3 lines there. So shapes is going to be a Boolean array. And it's going to be 3 by 3 by 6. 3 in the X, 3 in the Y, and then 6 shapes. Why not? So NSX, NSY, and NS. I'd rather not have hard-coded magic numbers. Then we can loop. And then shapes, all of the x's, y, I equals string vec. I have that helper function. String equals that. And then I should be able to print all of my shapes as a Boolean array, rank 3 array. What do you mean undefined? Utils, str vec. Vec str, okay. Transposed order of those words. So, we have a shape, we have like an I shape. So we have, is this transposed or something? Was that the input or what the hell? Why is that not right? For I, how did I fuck this up? What is going on? Did I transpose it? Because this is not an I-beam no matter how you transpose it. But that's like, isn't that the first shape? No. That should be the test input. True, true, true. Oh, I have a blank line that I need to skip. Okay, so this is an I-beam. We have trues on the I, and then we have false in like the hips of the I, if that makes sense. Okay, so we have the shapes, and then the rest of the file is going to be the dimensions and the numbers of shapes that we need to pack into that area. We could just do that line by line. So what are we calculating? How many are packable? How many regions are packable? So we actually don't need to know the number of lines ahead of time. We can just process one line at a time because each of these problems is independent. So we have 3 independent problems here. Okay. Wow, not EOF. Is that how I read until the end of a file? I don't like while loops. I'll just do a for loop. Uh, 0 through n lines minus 1. We have like 5 lines per shape. F is not open. Oh, because I closed it already. Okay, so we got 3 lines. Let me make sure I get all of the lines with the real input and like don't skip the last line because that could massively mess up my answer. 40 by 39. So that's the last line. Looks correct. Okay. Those are all the lines. Now we have to solve the problem. So, let nums equal parse I32 delim from the string, and the delimiters are going to be x, colon, and space, because we have an x, and then we have a colon, and then we have spaces everywhere else. So this will give me integers. All right. This might not be that bad, actually. Just a little recursion. At least I have recursion in Syntron this year. So now we have NSX and NSY for the shape dimensions. Now we're going to have like dimensions of the area that we have to pack. So I'm going to call that NX and NY. Nums 1. Then what's a good variable name for these? NSV, the shape number vector. I don't know. Nums 2 through 8. NS plus 2. Let me just verify that I got these, because if I get these wrong, that would be like really annoying to have not verified. Okay, so we have 12 by 5, and then 101032. That seems correct. Now we have to see if it's packable. And like I said, I'm just going to try brute forcing it. It should work for the test input. Not really sure if it's going to scale for the real input, but what was this number? I think we have like 3 million possibilities. So that should be brute forceable, maybe. Okay, so we're going to have a grid, which is going to keep track of if something is occupied. Yeah. And then we're going to do like a depth first search to try placing things into that grid. False nx by ny. Okay. And let's just stop after the first problem. See if we can get that one. All right. So we only have the next to the last shape, which is this like U-shaped one. It's like a sideways U, or maybe that way, if I get my camera orientation correct. And we can pack 2 of those into a 4x4 area, and they show you this here. Okay, so the first 2 are packable, and then the third one is not. So those are our expected answers. So I think this has to be like a recursive depth first search. I probably want to make sure I know how to rotate and uh, and flip. So you have flip left, right, flip up, down, transpose, which is like a diagonal flip. Or should I do the 4 rotations? Rotations seem difficult to program. So let me see if I can just do all of the orientations of a shape. I think 0 is a good example. Okay. Shapes. 0. This will be like a unit test. So, first of all, let's print this. This is a Boolean, but I want to print it in a way that's true and false have different numbers of characters. So when you print this, it's kind of hard to look at. It's easier to look at like this. So I want something that prints it like that. Let's have print boolmat. It's not big. It doesn't really need to be a reference. So let's implement this. Print boolmat. We have a message, and then we have the Boolean grid. And then I can just convert it to a character grid and then print that. So print that, and then make a character grid. It's going to be all dots. Size be 0, size be 1, and then C. Oh, I just have to iterate over this. That's annoying. Yeah, I thought I could do some fancy array syntax, but I just have to iterate. If bxy, then cxy is a hash, and then we can just print that and return. Okay, so we printed the original shape. Now let's see if we can get all 8. Because if I flip left, right, flip up, down, and transpose, I think I have to do rotations. Or can those give me all 3? Because I don't want to do rotations. They're only 3 by 3, so I could like just hard code it to make it work for 3 by 3s. transpose. Just want to see if the function signature is okay. All right. And then that just, it did a 1 by 1 because that's all it returns. Transpose is easy. I want to get the size all the time. Let's call it B T for transpose. False ny by nx. Okay, that should be transpose. So it should take this and it should put the 2 dots in these 2 positions. The diagonal should stay the same. So we should have a dot down here instead of over here. T, what? Yeah, true. Let's just do it this way, unconditionally. What? I still have to do the flips. Okay, so I have a feeling that if you flip left, right, no, both flips will not be the same as a transpose. So I think this might work. This might be able to give me all 8. Okay, so we want flip LR. Let me just copy the signature because that's easier. Let me just copy the whole function. Now left flip LR. We're still, T can be transformed instead of just transpose. Is it just nx minus x? I think -1. Yeah, I think that should work. But I have to call it, but the function signature is okay. LR, flip LR. Okay, so that took this and it flipped it over here. That's good. Now let's do flip UD. Got an extra new line down here. Flip UD. So this is just going to be X, and then we're going to have, let's get some spaces in here. And there's no math. I don't mind cramming everything together, but this is slightly more complicated. Okay, and this should flip it up down wise. All right, that's flip up down. Now if I do flip left right and flip UD, that's not going to be the same as transpose, right? And then I should be able to get all 8 orientations by doing some subset of these transformations. And maybe I have to encode that some other way. That's fine, we can do that. We are allowed to rotate, right? I'm not wasting time. Rotate, Presents can be rotated and flipped. Okay, good. It'd be a shame if I just did this for nothing after having misread the puzzle or something. Man, we're half an hour in already. I think once I get this, the brute forcing might not be that bad, but I still don't know if it's going to scale. Okay, so if I do 2 flip, LRUD, flip LR, then flip UD. Please don't be exactly the same as a transpose. So, okay, that's a new one. And then maybe I want something that takes like an integer index from 0 through 7 inclusive and does like an appropriate permutation of these. Transpose. We have the original 1, 2, 3, 4, 5. We have 3 more to do. So we can do. So we have the 3 basic ones of just a single transformation. Then we have both flips. Then we can do a flip and a transpose. And then we can do the other flip and a transpose. And then we can do all 3. So we have 8 lines here. Those are all 8 flips and rotations, I hope. Are all 8 of these different? Let me zoom out. So we should be able to get this dot in all 4 corners, and with this one on either side of it. So we have this, and then we have the transpose, which keeps the same corner but moves that one. So we have bottom right. How about upper right? We have upper right, and then kind of the transpose of the upper right. How about upper left? We have this, and the transpose of that. And then bottom left, we have this, and then this. Yeah, so that's all 8 permutations. I think that's okay. Yeah, now maybe I want one that just takes an integer index and doesn't make me think so hard. So these are the 8. How about I paste that first, and then I want the function signature. Transform. It's going to take the shape and an integer. So I'm just going to return one of these 8. Oh, deleted too many there. Okay, and we're just going to return one of those. So if I equals 0, return. And then 1, 2, 3, 4, 5, 6, 7. I hope that's a valid function. S naught. Right, it's not S naught, it's B. Okay, so can I just do this the easy way now? Should I test this? About number of transformations. Printable mat. String I equals transform S naught I. It should just print the same thing. Okay, that looks close enough. I'm not going to check them as thoroughly because this function seems straightforward. Okay. Now we have to do the packing. Okay. So how do we do that? I want like a recursive function that I can just call to place the next shape. Does it even need? I think it does need to be recursive. Does it? Yeah, because I might place a few shapes and then figure out that I can't place something, and then you have to backtrack to like repacking the first few shapes. So it has to be like a depth first search. I mean, breadth first would also be fine. I feel like there's a lot of stuff that I have to pass. I have to pass the grid. I have to pass this vector. Don't really need to pass these because I can just recalculate it from the size of the grid implicitly. And then I need like some sort of representation of like what's the next thing to try to pack. So we're going to have X location, Y location, the shape type, the shape instance, because we can have several of those shapes, and the transformation, 5. So it's going to be IX, X, Y, transformation, index of the shape type, and index of the shape instance. So we might start out on, we want to find like the first non-zero here. Because if we're not packing any of the first shape type, we just want to jump to this one. So this is the shape type. So it should be 0, 1, 2, 3, 4 for this one. And we have 4. Okay. And then in my search, I'm going to need to do this as well. I hope I remember to do that. Otherwise, I'm going to pack these two and then go to the 0 and try to pack that. But after I pack these two, then we're done. So I don't even know if this is the right way to do the recursion, but I've got to start writing code and hopefully get to bed at some time. Yeah, so search. And we're going to search on the grid. And we need to know how many of each shape we have to pack. Is packable. And the state. because this is going to be like a constant. And then as we pack shapes, we're going to iterate the things in the state. So like if we're going to try packing at position 0, 0 first with like every possible transformation that we need to try. And if we can't pack it, then we're going to try another location or another transformation. And then once we get one shape packed, we're going to increment the shape instance to pack the next one of that same kind of shape. And then once we pack all of those shapes, we're going to increment to the next shape type. Search. There's my function stub. Okay. Now what I think is the hard part. So we're just gonna try packing in this position. When incrementing ist, remember to skip zeros. Okay. So we're going to unpack things from the state. I just put it into an array so I don't have to have a million arguments in this function and update the signature every time I change something. This is so much. If he didn't make us do all like the flipping transformations, this might not be quite as bad. All right. I need the shapes, don't I? I could make some of these things global variables and then not have to pass them. Maybe that's the way. Yeah, but I need to pass this. Is that signature still okay? Nope. Bool. Oh yeah, it has an extra rank. Okay, now we're gonna apply the transformation. Trans shapes : ist shapes : ist. transform shapes colon shape type, and then transformation. And this should be this one with no transformation. And this is interesting. Shape. Oh, wait. That's. So the next to the last one, yeah, it's the U-shaped one. That's the first test. This needs a message. It should be the U-shaped one. IST is 4. Did I unpack this correctly? 0, 1, 2, 3, 4. Oh, because I never set this into the state. State 3. Okay, so that's the shape I was expecting. And then we're going to pack it at X, Y. Print line at position X, Y. And then we're going to see if it clashes with the grid of things that have already been packed. I think G should not be a reference because when we backtrack, we want to go back to a local copy of the grid. So I think that should not be a reference. So, check if packable. If anything in the grid is true and in the shape that we're packing is also true, that means we have an overlap that we can't pack. So that's a logical and if we have trues in both. And we're going to slice the grid to account for the XY position. And if any of them, I can't deal with these bots, man. If any G and S return false, so how do we slice this grid? It's going to be X through X plus NX, and then Y through Y plus NY. So that's a rank 2 array, and S is also a rank 2 array. Right, I have to get local versions of these. Except this is G. No. NSX. These are just 3. I could have just hard-coded it. but I have to update those. Okay. So it should be true, because we have nothing else packed yet. So that's packable. And then we have to put it in the grid. So it's going to be like or equals. So G equals G or S. After. So we should put this at 0, 0, which is going to be the upper left corner, and not transformed or rotated in any way. Okay, so that's that shape in a 4x4 grid. Initially it's empty, and then we put it in there because it's packable. Then we're going to increment to the next one, and this is the tricky part. Shit. No, because if it's not packable, well, that's okay. We can handle this in the recursion. So this is going to be the annoying part. It's like state is a big num, and we're incrementing this. No. Because if it's not packable, we want to increment x, y, or t. But if we can pack this one, then we can increment. First, we're going to increment the shape index, and once we pack all of the shapes of that type, then we go to the next, we increment ist to go to the next shape type. Okay, we might be getting close here, but we're not done. I hope this is a one-part day. So first, increment shape instance isi. Then increment shape type ist if we've exhausted everything of this index. So, so instance 0, and then we're going to recurse here. So if isi is less than nsv ist, so state 4 plus equals 1. And then we're going to recurse. return search same grid with like this local copy of the grid, which can vary with the recursion levels. Same shapes, same NSV, and then we modified the state. So this should get to 2, and then I think it's just gonna increment a lot. So we do 0, we do 1, and it's not packable because we haven't done the X and Y transformations yet. Yeah, so we're gonna have to get to that. But here, this is so annoying. If X is less than NX minus NSX, because our shape takes up 3. So in the 4x4 problem, we can only slide it over by 1, because otherwise, like, the other corner of the shape is going to overflow the bounds. Then state 0 plus equals 1. And like down here, I want to reset X to 0, because then I'm going to increment Y. And then recurse. But that's not going to work either. And then I need NX and NY. Okay, so we try packing at 0, 0. And then we try packing at 1, 0, but it's not packable there either. So what we're going to have to do for the sample is, hey, elemental magics, welcome to the stream. What we end up having to do is slide it 1 in the X and 1 in the Y, because this top left corner of the shape, it's 1, 1 away from the origin. So we have to transform X and Y, and then we have to like do a rotation or something. So we're going to have to end up incrementing that too. You worked with Fortran for only a few years. You got to give it longer than that. You got to give it the old college try. I'm not a functional programmer. I tried Lisp a little bit briefly, and it's just not my thing. So to each his own, I guess. Okay, so we try incrementing X, and then if we're about to overflow X, then we're going to reset X to 0. Reset X, and then we're going to try incrementing Y. Y less than NY minus NSY. Same idea, but increment state 1 instead. And recurse. Otherwise, reset Y. And then we can increment the transformation. If t less than nt, nt is just 8, but I think I have to... I'm just hard coding these constants in multiple places, which is worse than just, you know, hard coding magic numbers. I should have just made them global variables. Honestly, that would be the right way to do it. So t is state 2. State 2 plus equals 1. Isn't this... I think it has to be minus 1. No, because where did we end up? Oh, we did 1, 0. No, I think this is okay. And recurse, and then I don't think I have to do this because we're returning false here anyway. Because if we've tried all of the locations and all of the rotations and flips, then it's just not packable. With transformation T. All right, now I still have to do this. I have to increment to the next shape instance, but the first line of the sample input only has one type of shape. So got to the end without a return. How do we get to the end of this without a return? This returns, this returns, this returns, and then we return false. Is this a bug? It certainly tried a lot of things. So we packed the first shape. Oh, trans. Oh, because this... Yeah, I think this has to be -1. I don't know why x and y don't need an extra -1. I was thinking it reached the end of this function without a return statement. I don't have good compile time logic flow checking, so this is a runtime error. I should have read which function was problematic. It wasn't the recursive one, it was just the transformation one. So I called it with like t equals 8 when it has to be between 0 and 7 inclusively. It should have been able to pack one of these though. Oh, yeah, it did. So it did this. And then I need to check if I'm done. I think we might be almost done with this problem. If this will scale for the real input. Okay. So we increment the shape instance. We did this because we packed 2 of these shapes. And then shouldn't this have a -1 as well? What is shape instance ISI? Which part of the state is this? State 4. And then we're going to go to the next type, or we might be done. And for the first example, we're done at this point because we pack 2 of these shapes, and then the rest of this is zeros. So It's going to be like this loop, but we also have to check if we get to the end. So while ist, we have to increment it by 1. Yeah, but it's going to overflow if I'm not careful. So ist plus equals 1, and we have to put this back in the state. So state 3, I think. State 3 is the shape type. These indices are hard to remember. I probably could have done this a better way. But I really didn't want to pass like 5 scalars to this function. So I wanted to pack them into an array. Okay, so how do we do this? While true, if ist equals the number of shapes, that should be 6. Is this in this function? This might not be in this function. We're done. If NSV ist not equals 0, we break because we found the next shape instance, or shape type. And otherwise, we increment this again. I think that might be it. Oh, and then we have to recurse. So, and then I can take out that dummy return false, just so I don't reach the end of the function without a return statement. So G shapes, I think that might be it. Yeah, NS doesn't exist. This is terrible code. Don't write code like this. So that says it's not packable. But we packed this. We should hit this. Why didn't we hit that? What type are we trying to pack? What happened here? Because I saw it getting packed. We packed it here. This is like the interlocking use. This is correct. And then we should like increment this stuff. And we should realize that we're done. The state. Does the state have to be a reference? Fuck. After. So we got something that's packable. 0, 1. We shouldn't do 2. We should have instance 0 and instance 1. So this needs a -1. Okay, that's packable. Man. I hope I'm done. We just have to count how many of these are packable. Well, that didn't work. We only got 1. If I problem equals 1, let's debug the second one, because this one should be packable. Let me just modify my test input. Let me put this one first, because there's just too much stuff to scroll through. This one should be packable, right? I probably have like another -1 that's wrong. I don't know. So this one should be packable, right? Second region can fit. This one is crazy. 12 by 5, 101022. So the third line is just the second line with one more of these. So we packed 1. And we pack a few. And then after this, so we pack a few. After this, we fail, and then we backtrack. So is that like the first shape rotated? It's like the same first shape again. I only have 4. I thought this, no. So it's not really recursing correctly. I don't know if I can do this. It's getting late. Shape type. Zero, 1, 2, 3, 4, 5. Uh, I don't think I'm searching my state space correctly. I don't know, man. This function is so long. It's 80 lines, but it feels so complicated. I don't think I can do this tonight. See, people say that, like, the last day of Advent of Code is supposed to be easy. Like, oh, it's the last day. Eric's giving us a break. That has almost never been true in my experience. There was like 1 year where I thought we got an easy problem on the last day. But I don't think today is an easy day. I feel like I could do this eventually, but I'm just not going to nail it on a work night at 1:30 a.m. So I got the first one because I never had to move the first shape. The first shape, you can just put it wherever, and then there's some way that you can put the second shape. Did I have to transform it at least? Yeah, so I never had to move with T2. T0. Yeah. The first shape, you just put it at the very first position and transformation that you try. And then you go through the iterations of how you have to move and rotate the second shape. So that works. But I'm not getting the logic where you can't get the second shape in, and then you have to backtrack and try putting the first shape in a different position. Is it really return false? Or is it decrement the shape and go back and try the last one? Like, can I put that logic in here somehow? What you need here is a backtracking algorithm. I've written Sudoku solvers like this. I have one in the Syntran repo, I think. Sudoku. This is 200 lines. Yeah. This is what I need. It's not just a depth first search. This is called a backtracking algorithm. And this has like a whole Wikipedia page, I believe. That's where I did this originally. I did Sudoku and something else a long time ago. I'm not sure if it was Fortran or Python. And I did the same Sudoku thing, which I ported to Syntran here. Wikipedia is, I swear there's a Wikipedia. Backtracking. Why is Wikipedia not just the first Google result? Yep, so this is the pseudocode for backtracking. P is like your state. Procedural parameters. Basically what I have is the state. And then you check if it's packable. You check if it's not packable. And I think, is except just the, except means we're done. So have we packed all the shapes? Reject means we're trying to put a shape in a place where it won't go. And if it doesn't fit, then you return. If everything is packable and you're done packing all the shapes, then you accept and you print your answer. And then here's where you do the recursion. So you start with the first state, which is just 0, 0, 0, except for like possibly the shape instance. And then you do this stuff. And then I have the logic for incrementing the state. All the, like, if x is less than nx, then increment x, otherwise reset x and go to y. Like, I have all that logic in there, but I think I put it in the wrong place because I was thinking of this is just a depth first search problem. But I got the logic wrong, and this is the right logic. And you can see I've done this before, but I wasn't thinking of it. Now that like the depth first search thing failed, I've realized that I think this is the way to go. So I guess I'll try this tomorrow, but I am not getting this tonight. It's 1:30. I don't want to port all of this. Oh, and apparently I had some this isn't so fast in Syntran. Syntran is not efficient. I did use references. I don't know. So we have reject. Reject Sudoku is like if you have 2 9s in the same column. That's rejected. So you check the columns, check the rows, check the 3x3 subgrids. Except means you filled in everything. You don't have any zeros left. You're done. First is just like the initial grid. Next increments which square in the Sudoku grid you're trying to fill in. And this is a 2x2 grid, so it's kind of like big num arithmetic. And then the backtrack itself, it's basically just this. So If reject, return false. If accept, return true. I'm not sure what I'm doing with this last variable. We get the first. And then while s is not null, while. Okay, so I'm using last instead of some null check because I don't have null in Syntran. I don't know why I changed this logic a little bit. Because this returns something. So when this is done, it returns true. So that's my ending condition. And then solve Sudoku is just a wrapper around backtrack Sudoku for the first recursion level. So I think I can port this to today's packing problem. But as I said, I'm not doing that tonight. So I think I'm going to commit what I have because some of this code is going to be reusable, maybe, once I get this figured out. Am I on day 12? Yeah. I don't know if you were watching a minute ago. So I tried like a depth first search kind of thing, but it doesn't really recurse correctly. Oh, you didn't start. Oh, well, yeah. I'm not going to spoil anything then. Unless you want me to. I'm about to give up. I think I know how to solve it, but it's 1:30 a.m., so I'm going to go to bed. Try it tomorrow. It's not day 10 hard. Like, I know how to do it without cheating. I think. I mean, it could always turn out that my plan that I think is going to work doesn't work either. Maybe. There was... I can't remember what the really hard day 25 was. Let me try to not spoil anything. Sorry. Stayed on that screen too long. Events, was it 2023 or 2024? I think 2023 had a hard day 25. Was this? Oh, no, this was the one you did with GraphViz. What was, well, I did 2024. It must have been 2022. Oh, good. So I didn't spoil anything. Full of hot air. No, I don't remember this one either. This was too long ago. I just don't remember it. Yeah, I don't know. I can't remember how hard a typical day 25 is. And I didn't get part 1, so I don't even know if there is a part 2. Oh, ignore my tabs. My tabs are spoilers. Ignore that too. Day 10 was brutal. Kudos to you. I think you're the only person I saw solve it without a library. Yeah, those elves, they always have tricky questions. I think some of my code is reusable. All right. Are you about to start streaming? I might watch you, like, wrap your head around this problem. I don't know if Dave is going. I saw Dave working on, like, day 11? No, day 10 earlier. Maybe I'll watch Dave if you're not about to hop on. Sort the human genome sequence. Did we have genome problems one year? That sounds familiar. Stu is on. I guess Dave went to bed. Maybe I'll raid Stu. Last time I tried to raid somebody, my OBS stream crashed because my laptop can't handle watching somebody and also streaming. What is his name? Stu Squared. Well, I better do it without watching. Raid Stu Squared. All right. Thanks to everybody who tuned in. I really appreciate it. And I will catch you next time. See you.
It's a lot of fun. I enjoy Factorio. There's a game I want to play, and possibly on. Oh, hey Jeff Irwin, how are you? How'd your admin of code go? Introduce every kid to Factorio. Yes, totally. Introduce every kid to Factorio. Are you familiar with any of the games by? Crap. So there's a game called Shenzhen IO. And this one is basically you are building things in assembly. So I'll find some screenshots or something. It's a Zachtronics game. Zachtronics has all kinds of games like this that are like low-level computer stuff. And this game comes with a manual, so you can print out like this 100-page manual of schemas for all this hardware and like documentation for all the pieces that you're using and wiring together. So you wire these together, you write some assembly, and then you build little hardware things. You love Exapunks? Yes, I'll enjoy that. I think I'd like to play that on stream. That seems really fun. Yeah. Good start. Try, what is that? KOHC. Shenzhen is a solitaire card game. So is Balatro. Balatro is another game to avoid. Or Balatro. I think that's how you're supposed to pronounce it. But Balatro has a better ring to it to me. Every Zachtronics game is a solitaire game with a programming puzzle minigame. Fair enough. But yeah, any automation game is like addictive. It's really for constructor. You make a CPU by drawing PNP traces. Okay, let me try and copy paste. I might have to look that up, and I might have to play it. Engineer the people. Interesting. Oh wait, it is another Zachtronics game. Cool. He plays an engineer working in a semiconductor factory, designing circuits based on specifications. Cool. Zachtronics games for sure. I'm into them. The food court game from their, so there's a mini game inside of their last game. I think we're making some headway here. So we found the 4 elements that are terminal. We'll We'll call them terminal elements. And we could do the counts of them. So let's take the medicine. Medicine dot elements, or no, just elements of medicine. And then let's get the size of that. And val, what do you call this? Terminal